Yes, today, guys, I'm going to introduce the machine learning again. Like, there's another series of machine learning. So, in which I'm going to tell you the number of assignment that we have, and this is I feel that it is very important to share with all of you. So, let me discuss this one by one. Uh, like, you can say in the sense of machine learning, what is the first question? Like in the sense of what is the model and what is the best way to train a model? Okay. What is the in the sense of machine learning? Explain no free lunch theorem. We have to describe the k-fold cross validation mechanism. That is also important. Describe the bootstrap sampling method. What is the aim of it? What is the significance of calculating the kappa value for a classification model? Okay, so how to measure the kappa value for a classification model using a sample collection of results? Okay, describe the model ensemble method in machine learning. What part does it do? Right? What is the descriptive model's main purpose? Give example of real world problem that descriptive model were used to solve. Right? And what is the next question? You can consider describe how to evaluate a linear regression model, and you have to find the distinction between descriptive versus predictive, underfitting versus overfitting, bootstrapping versus cross validation. Okay, make quick notes on where you have to make a quick notes on LOOCV, key of measurement, the width of uh, silo head kind of, right? So I think that is a very important. Receiver operating characteristic curve, that is also very important. So there's all of the questions are from assignment number 6, and like as I told you that very important k-fold cross validation. We basically use calculation for overfitting problem and underfitting problem. So yes, like that is very important. If you are coming to assignment number 7, yes, we have some target function, and in those target function, we are supposed to explain some target function. Like we need to check that how the fitness is set with the real life example, right? Next question is that what is the predictive model? How do they work? What are the descriptive types? How do you use them? Example of both the types of models should be provided. We have to find the distinction between the form of the model, right? Okay. Describing the model of accessing a classification model is also the detail. Describe the various measurement parameters, right? But the next question is that in the sense of machine learning model, what is underfitting? What is the most common reason for underfitting? What does it mean to overfit? When is going to happen? In sense of model fitting, explain the bias variance trade-off. Is it possible to boost the efficiency of a learning model? If so, please clarify now. Okay. How would you rate an unsupervised model success? What are the most common success indicators for an unsupervised learning model? Is it possible to use a classification model for numerical data or a classific regression model for statistical data with a classification model? Okay, so what is the question? Is it possible to use a classification model for a numerical data or a regression model for the classical data with a classification model? Explain the answer. Describe the predictive modeling method for numerical value. What distinction it from critical predictive modeling? The following data were collected then using a classification model to predict the malignant of a group of pattern tumor. Accurate estimate 15 cancer, 75 malignants and wrong prediction 3 cancers. Determine the model error rate, kappa value, sensitivity and precision and gap measure. So these are the value that you need to calculate that is related to your you can say confusion matrix. Make cube notes on process of the holding out cross validation by tenfold, adjust, adjusting the parameter, defining the following terms: purity versus piloted weight, boosting versus wagon, the eager learner versus the lazy learner. Okay, that's completely fine. So I believe that this is all important, and I believe you should all understand this properly, right? And if you are coming to assignment number 8, yes, like what is the first question in that? What is the feature? Give example of that. Give various example of feature construction. How does nominal variable encoded? How the numerical features are converted to categorical features? We have to describe the feature selection approach, state the advantage and disadvantage of this. What is the feature considered relevant? What can be the set to quantify it, right? What is the next question? Or what is the function considered redundant? What criteria are used to identify features that could be redundant? Okay. What are the various distance measurement used to determine feature similarity? Is the difference between Euclidean and Manhattan distance? Okay, that is completely fine because using KNN. Distinct between feature transformation and feature selection. Okay, we have to make a brief notes on SVD, that is called standard variable diameter collection of feature using a hybrid approach. The width of the COTT receiver operating characteristic curve, right? Uh, okay, that's completely fine. I believe this is completely fine. What is the feature ending? How does it work? Explain various of the feature ending. What are the features and how does it work? What is the aim of it? What are the various methods of consideration? Describe the function selection, filter, and vapor approach. State the pros and cons of each approach. Describe the overall feature selection process. Explain the key underlying principle of feature extraction using an example. What are the most widely used function extraction algorithm? Describe the feature engineering process in the sense of a text categorization issue. What makes cosine similarity a good metric for a text categorization? A document term matrix has two rows with values of this and this. Find the resemble in cosine. What is the formula for calculating having distance between this and this? Calculate the having gap. Compare the Jaccard index and similarity matching coefficient of two features with the value this much and this much. State what is meant by high dimensional dataset. Could you offer a few real life examples? What are the difficulties in using machine learning techniques on a dataset with many dimensions? What can be done about it? Make a few quick notes on. PCA is an acronym for personal computer analysis, use of vectors, embedded technique, may make a comparison between sequential backward exclusion or sequential forward selection, function selection method, filter versus wrapper, SMC versus Jaccard coefficient. Okay, that's completely fine, right? I think you are getting all this point. Okay, fine. So define the Bayesian interpersonal probability. Define probability of a union of two events verification. What is joint probability? What is formula? What is Chandler probability? What is conditional probability? What is the formula for it? What are the continuous random variable? What are the Bernoulli's distribution? What is the formula of it? What is the binomial distribution? Achha, what is the Poisson distribution? What is the formula for it? What is define the covariance? Define the correlation. Define sampling with risk experiment. Give example. What is the sampling without risk experiment? What is hypothesis? These are the common questions that you need to understand, and it is look like a very important problem, right? So I believe this is all correct. So after this, there is a CSV. So I would request you to go through it all this. Bayesian interpersonal probability, my probability of union of two events. What is joint probability, Chandler probability, conditional probability, confirmed. So these are the Bernoulli distribution, binomial distribution, Poisson distributions, covariance, correlation, sampling with this. There are all these questions that you need to understand. Okay, thank you very much for your time.